my absolute pleasure this afternoon to invite you all to the Bekey Institute EE Pioneer Series. I am Bhaskar Krishnamachari, the co-director of the Institute. Kathy Huang is our business officer, and she's helped put together this event. The Bekey Institute is a part of the Bekey Department of Electrical Engineering, and this has been a series where we honor and get to interact with some of our most amazing faculty pioneers in the department, going back to many, many years of wonderful service and achievement, and really people that are inspiring models to faculty and students in our department today. This particular EE Pioneer Series talk is also co-hosted with the School of Engineering in the Dean's Office and is part of the Remarkable Trajectory Series. And therefore, I would like to ask our Dean to come and introduce our speaker. I just want to say one quick thing. Mr. Bekey's slide introduces his talk as being an EE pioneer in quotes, but I assure you that we don't see him as a pioneer in quotes, but a pioneer without double quotes.
Thank you, Bhaskar. So I want to welcome all of you here today on this great event. As you know, this Pioneer Talk is being co-hosted, co-branded with the school's Remarkable Trajectory series we started about 3 weeks ago this year to honor faculty who have been retired. George retired from the University of Rome in 2002, but he really is not retired. He has been here pretty often in visiting the school, very, very often actually. And he was responsible for putting together a wonderful book about the history of the school since the mid-50s until now, which is called, actually is a volume 2 of the school's history, which is actually aptly named A Remarkable Trajectory from humble beginnings to global prominence. I mean, come on, how can you be better than that? And actually, our own president, CL Max Nikias, as you know, last week, the Wall Street Journal came up with different rankings about the university than the U.S. News and World Report. The U.S. News and World Report had rankings to, the USC ranked about 23rd or 24th for a long time now. But the Wall Street Journal is using a different methodology and ranked USC at number 15. So within a year, there was a quantum jump on our rankings from 23 to 15, and Max has been extremely happy with this, and he's been coming here, he's been asking about how to spread the word about this improved ranking. So I'm doing my duty to spread the word about the USC rankings, which is number 15, and that's obviously global prominence rankings for sure. George joined USC in 1962, coming from a university across town here called UCLA, which in the new rankings, according to Max, enthusiasm announced that UCLA was ranked number 26. USC is number 15. So he could get to he acknowledged that particular fact. And then George has been a fundamental part of the pillar actually of the Veterinary School for all the years that he's been here. 40 years as an active faculty member, when he retired in 2002 after that, as a tremendous supporter of the school in many other activities. So actually this counts 54 years of engagement with USC. So that's amazing. It's almost a record. I'm almost sure it's a record. And it's a wonderful testament to your impact to the school. He has chaired the W department from 1978 to 1982, 1983. I remember the year 1978 very well because it's the year that I joined the university. And then he was also the chair of computer science department. Actually, I knew George more as the chair of computer science than at W. And then he also shaped the Department of Biomedical Engineering as well.
You never chaired it.
You never chaired it.
Oh, I started it, but I never chaired it.
So that's another tremendous impact that in three key departments in the school. He was also an associate dean for research from 1997 to 2001, if I am not mistaken. I was the department chair of chemical engineering as part of that time, and the thing that I remember was a request that the dean's office had to charge 25% tuition on academic grants at the time, and we went there and revolted with that, atrocious idea to charge tuition into a federal grant. Of course, from the dean's office perspective, I thought it was a marvelous idea. No. And I completely endorse it, George, after the fact, maybe 25 years later. It's a pleasure that the school has been associated with George, as well as with his daughter Michelle, who has been involved with ISI for quite some time now, and she was also instrumental in putting the book together. It's a book I think that will stay for a long time as a record of the number of faculty that went through USC, as well as the impact that the school has in shaping sort of the modern engineering in many multiple ways. So it's with great pleasure that I want to welcome George and welcome you to this very important series.
Thank you very much. Thank you very much, Giannis. It's a great pleasure to be here. As Giannis said, I've been around for a long time, and I actually came to USC in 1962 after getting my PhD from UCLA. And those were the days, for those of you who read my book, will remember we used to say that if you flunk out of UCLA, you can always go to USC. Those were the days, and this is no longer true, thank goodness. Very, very true. Okay, so let me tell you the story as best I can. My goal is to try to give you a feeling for the early days, the pioneering thing as much as possible. Okay, let's see if this thing works. By golly, it does. So there's a summary of what I'd like to do. Tell you my own academic history, some of the major research areas, and comments on some selected unusual projects. My projects have frequently been unusual, or maybe the better word is weird, but anyway. That's the way it has been. So this is the beginning of my academic career. This is my first day of first grade. I was 7 years old. And since I'm now 88, this was 81 years ago. And this was in Prague. I think that marvelous backpack that I'm wearing is wonderful from those days. So. And you can see I had more hair in my face. Okay, so as I say, I started elementary school in Prague. Then it was too late to leave for the United States when Hitler rose into power in Germany. We managed to get out of Czechoslovakia and go to South America. We were in Bolivia for 5 years, waiting for our number to come up on the U.S. immigration quota. In those days, the United States immigration was based on the nationality, and we admitted so many French and so many Germans and so many Czechs and so on. And so we came on the Czech quarter, but it took 5 years for our number to come up. So we were in Bolivia for 5 years. When our number came up, we moved to Los Angeles. My uncle Stanley had been in Los Angeles in 1933, and my dad thought about coming at the same time, but then he had an electronic business. He made the first cable model radios in Czechoslovakia. And he said the business is going so well, and Hitler is enough, they'll put him down. Anyway, when we left, it was too late. Okay, so that's the story. I went to Manual Arts High School in Los Angeles from 16 to 18. I graduated at age 18. In spite of moving from one country to another twice, I managed to cash up and graduated at the age of 18. Then I went to UCLA. Actually, I applied for Caltech. So I thought I was going to be a great engineer, and I was going to go to Caltech. But it was 1946, and that was the end of the war, of World War II, and there were tens of thousands of people wanting to get into all the universities, and I couldn't get into Caltech. So I went to UCLA, which was actually a wonderful decision for me. So I was there for 3 years. UCLA was just starting its undergraduate program. When I was to be a senior in 1949, was the first year that UCLA offered the senior year. And several people advised me, don't be a guinea pig for the senior year, go to Berkeley. So that's what I did. I went to Berkeley, I graduated in 1950 from Berkeley. And in those days, I was an electrical power major. My dad had been in the electric motor business, and he had a number of patents for electric motors. So I went there. Anyway, then I returned to UCLA, got my master's and my PhD. So that's the story on that. Okay, a few significant events. In 1951, I married a remarkable woman to whom I've now been married 65 years. People can see that. From 1950 to 53, I worked on a mechanical computer, and I'll show you a picture of it in just a second for those of you who haven't seen it. Actually, a remarkable machine. Then, in 1952, I had been influenced by a man whom I heard speak at a conference, and I thought that maybe I really don't want to be an engineer, maybe I want to be a minister. So, USC at the time had a seminary on campus, in the School of Religion. It was actually an accredited Methodist seminary. I enrolled at USC in religion, but at the time I was still working on this mechanical computer in UCLA. And I kept that job because that was the only money we had. So I spent mornings, most of the mornings, maybe 3 days a week I was at UCLA in the morning, and 3 days a week I was at USC in the morning in school. So it was kind of going back and forth. Greetings. Nice to have you here. So that was the story. The first year in the School of Religion, I was admitted with a huge undergraduate deficiency because, like all engineers, I had no humanities as an undergraduate, the required 3 courses. So then it took me a year to get caught up, having taken the Psychology 101 and Sociology 101 and other things that I already had. And so then came the more interesting courses, philosophy of religion and stuff like that. So in 1956, I dropped out because after studying the theoretical issues in religion, including Buddhism and Hinduism, which I was very interested in, we got to the courses that had to do with how do you run a church, and I couldn't stand it. So I dropped out. So the theory and the philosophy were wonderful, but the idea of raising money didn't appeal to me at all. So then, as soon as I dropped out, the selective service caught up with me, and I spent 2 years in the Army, from 56 to 58. Then eventually I graduated in 1962 from UCLA and joined the electrical engineering department. Here we are. So this is the computer I worked on at UCLA for 3 or 4 years. The man that you see there is Vannevar Bush. If that name rings any bells with any of you. Bush was actually the founder of the National Science Foundation, among other things. So it is a very distinguished role in our country's technical and engineering history. He designed and built this machine at MIT. And it was a mechanical differential analyzer, meaning by that you could solve differential equations. And this machine actually had 14 integrators. So we can in principle solve 1/14th order differential equation, or 2 7th order differential equations, right? So the analogy was a rotating shaft, so that there was one major shaft which was represented time, and then gears connected into other shafts. Those gears were multiplications by constants. We had little differentials, like the rear end of a car, which were adders, so we could add up 2 rotations and get something else. And with some difficulty, we created multipliers. And it was actually a fascinating machine. Bush was also, in addition to having founded NSF, he was really the designer of what I like to call the science-based engineering curricula in the United States. Prior to Bush, who was named to that role by either Roosevelt or Truman, I can't remember, but it may have been Roosevelt initially. Prior to Vannevar Bush doing this, engineering to get a degree in engineering, you have to build something physically. It would be an engineering device that you designed and built. The idea of having a science-based engineering curriculum was due entirely to this guy. And we inherited that, and of course, that's who we are at the present time. So, of course, people accuse us at night of grinding hamburgers on this machine. And one other interesting thing is that because the rotation of a shaft represented the value of a variable, if a derivative was increasing, you could hear the shaft speed up. So we had acoustic feedback. All right, so here's how the integrators work on that machine. For those of you who haven't seen them, so the independent variable x rotates the large wheel, and then there's a small wheel that rides on it at a distance y from the center. So the output dz is just equal to y times dx. This worked very well, except for the fact that obviously that wheel couldn't slip. Because if it slipped, then you don't get rid of the US. So the computer we had on campus was one of 9 at UCLA, with 9 built by General Electric. And they did a very clever thing. This wheel that you see here, so this wheel that rides on it actually was made of polarized glass. And behind that little shaft that you see going out to the right, behind an entrance to a darkened area, there were 2 other similar wheels, polarized, one 45 degrees leading and the other one 45 degrees lagging. So if this wheel turned a little bit, say, to the right, you'd get more light through one of those and less through the other one. And so servos then followed the wheel so that you could follow the direction without putting any load on it. Obviously, if you put any load on this little wheel, it would slip. So that's the way it was done. But as I say, we were accused of grinding hamburger and other things as well. Actually, that's the kind of stuff that people circulated around. So there's the machine, and as you can see, one guy has his hand stuck in there somewhere. Arbitrary functions were entered from these tables, like the one that you see in front here, in this area. Okay. So a person stood back here. Let's say that you wanted to enter a follow a pulse of some kind. So somebody would stand there with a crank and follow a crosshair up the crank and down the other side. The true spirit of a differential analyzer operator was exemplified by a guy who, as he was cranking up a pulse of some kind, his necktie got caught in the gear. This gear down below there. Okay. And so this guy, with a true patriotism, estimated the length of his tie and the height of the pulse, and you could see him cranking down further, and then back up. Well, we also, there was an emergency stop in various places along here to stop the machine in case of danger, and the instructions always were, don't hit the emergency stop unless somebody goes down for the second time. So that was that. All right, so my PhD committee at UCLA, I had Louis Pipes for applied math. I don't know if any of you use this kind of applied mathematics. It was an outstanding book. Walter Karpus was for analog computing, and John Lyman for man-machine systems. We called them man-machine in those days. It was before equality for women, so now it's called human-machine systems. So, and Vianney's for control. I also went to Kaplan. Dean Belter at UCLA at the time encouraged us to have one field in something outside of engineering to increase the breadth of the field. So I went to Abraham Kaplan, who was a famous philosopher. His field was philosophy of science, and I had actually ordered a class of this called Philosophy of Space and Time, most remarkable classes I ever took. Anyway, I went to see him and asked him if he would be willing to be on my PhD committee. And he said, well, sure, come and see me next Tuesday and I'll tell you what I'd like you to learn. When I came to see him the following Tuesday, he had a stack of 25 books. on the floor of his office, and I changed my mind. But anyway, that was the story. In 1955 and 56, I was in the Army, as I mentioned earlier, and this was the peacetime Army. Korean War was over, so we had Wednesday afternoons off. At a conference, at one of the Western Regional Computer Conferences, I went to, at a booth that Beckman, the Berkeley division of Beckman manufactured analog computers at that time. I went to their booth at the show and asked if there's any way I could get a part-time job. And they said, well, you know how to operate an analog computer? And I swallowed 3 times and I said, yes, but the only thing I'd operated on was that mechanical computer that you saw with all those gears.
Which was analog? That was analog.
That was analog. So that's what I said. I did operate an analog computer, but I knew zero about electronic analog computer. So anyway, they said, sure, come and see us next week. And so it's like, I went to see them, and they said, well, here's the computer we'd like you to work on. And so it was afternoon. Everybody was getting ready to go home at 5 o'clock, and I stayed all night and taught myself how to use the computer. So when 7 o'clock in the morning, I was finished, and the following week I wrote the instruction manual for the computer. So it was actually a great experience. So then came back to LA, and Beckman asked me to organize a computer center for them, which I did for service to industry. So I ran a computer. It was near Beverly in Vermont. So we did service to industry for them. In 1958, I went to Space Technology Laboratory, and they particularly hired me to see if I can put together a hybrid analog digital computer. The story was the following, that in order to be able to simulate the flight of ballistic missiles, we needed a digital computer for the precision of the flight to 5,000 miles from here to Russia, you see. But we needed the speed of the analog computer to handle the dynamics of flutter and rotation. So it turned out, so anyway, I was hired, we got the money to put together a computer. We got a computer from Beckman and bought a digital computer from IBM. And after, whoops, the whole computer. I must have accidentally turned it off. Huh? Oh, there it is, thank you. Okay, so, yeah, so what happened was that it took so long to get that hybrid computer debugged and working that by then the Air Force didn't wait any longer, and they began to launch the missiles without having us compute the trajectories in advance. And they worked, and so that was the end of that. About this time, before I left from UCLA, the dean, who was, he sort of liked me because I was a person with broader interest in most engineers, introduced me to the dean, to the incoming dean of the new engineering school at UC Davis. There was no engineering school at the time. But I forgot this guy's name, introduced me to him. And the guys made the following offer to me. He said, you know, what I hear from Dean Belter, if you're a person with broad interests, I need somebody like you to help me organize the School of Engineering. So here's what I'll do for you. If you come to Davis, I'll make you an associate dean and make you an associate professor with tenure, so you don't have to worry about tenure, and you can help me organize and run the school. What a tempting offer, right, for a guy just getting his PhD. So it was very tempting, and I turned it down. Because I realized that if I did that, I'd never do any research. I would be an administrator from day one. And so I turned it down. And I'm glad I did. But it was, it's nice to have it as a memory. Anyway, after turning that down, I was trying to figure out where to go. I had an offer from the University of Michigan. And then Balakrishnan, who those of you who are in communications, of course you know his name, Bal and I were friends for a variety of reasons. We had kids in Boy Scouts and Indian guides and things like that. So we knew each other very well, and our wives also knew each other. They were in school of social work together. Anyway, so So Val said, you know, if you haven't thought about it, I think you should go try USC. I hear there's a guy named Caprillion who's really turning that place up and down. So I did. I called Caprillion on the phone, arranged for an interview. I came to see him, and after 2 or 3 hours, he offered me a job. It was sort of Caprillion typical, right? I mean, if you like somebody, you'd offer him a job, otherwise you'd never get an offer. So, what he did, this was typical of Caprillion, for those of you who knew him, he was not the dean. He was not even the department chairman. The department chairman was Homer Grand, who was an acting chairman because he was the true chairman of industrial engineering. So, but he took an offer, had Homer Grand sign it, then he went to Ingersoll, who was the dean, and had him sign it. And he himself, Caprillion, had no no administrative position whatsoever. But a couple of weeks later, I got an offer letter. Some of you have seen it, it's published in my book. I was offered $700 a month as an assistant professor of electrical engineering. Those of you all electrical engineering, you know what this is all about. So, and then, so then I started a computer lab in Olin Hall on the second floor. But we immediately got into trouble because the computer center on Jefferson said they were had the sole right of using the word computer. So we changed it to simulation laboratory. Okay, so that was that. Now, interesting advances. We'll go to the next slide. Okay, that's fine. So that's what I look like. That's what I looked like when I came to USC. Just like I do now, except with more hair. In 1962, also, Walter Karplus, whom I knew not only because he was on my committee, but he and I actually co-authored a paper a year or two before that. So we offered a short course, a summer short course in hybrid computing, hybrid analog digital computing. And this was of interest to the aerospace companies, particularly because what was then Space Technology Laboratories, they were trying to build ballistic missiles for the Air Force. And the idea was that you could do the high-speed dynamics on the analog part of the computer and the trajectory on the digital part. As it turned out, we never got the thing debugged and working properly. And by then, the Air Force didn't want to wait any longer, so they just flew a missile and went flying. So that's what happened there. But anyway, we published a book. This was the main selection of the Computer Book Club, which existed at that time. And the book was $13.95, but if you're a member of the computer club, you got it for, as you can see, for $9.95. I looked about a month ago to see if I can find a used copy, and I found one for $73. So I came here in 1962. I was the 8th E faculty member at that time. So it was not a very big department. I shared an office in Beagler Hall with Nasser Nahi and Bob Gagliardi. Unfortunately, neither one of these wonderful guys are with us any longer. Nasser, as you know, died of a brain aneurysm a number of years ago. He was a truly wonderful person. Excellent teacher and so on. Anyway, in 1964, 2 years later, I was promoted to associate professor and then professor. 1972, I was elected fellow of the IEEE, and then a few other things that happened after that. Okay, so and I retired officially, became an emeritus professor in July of 2002. So that was 40 years after the 1962 when I started. Okay, so teaching. So in 1963, when I came, I introduced a class in hybrid computation because I've been doing that at UCLA. I also taught Fortran to freshmen, very good experience. But anyway, and I was, having had this old, long background in analog computing, I did the first course of digital signal processing. That was actually, somebody had told me that I'd be pushed through an A to D converter, because the year after that, I killed all the analog courses. My colleagues were very nice, since I had introduced them, they let me take them out. So that's what I did. I was also among the first 4 faculty members who started biomedical engineering. And I should tell you a 2-minute story, I don't want to go too long, about the training grant. So what happened was, there were 4 of us on the faculty of biomedical engineering. And and we desperately needed money. We had $0. And so I had by then had met maybe a dozen faculty members in the medical school, and also on campus in biochemistry and a few other areas. So I went to all of them and asked them. I first organized a meeting and then I went individually, and then I asked each of them to write a section for a proposal to NIH for what they could do if I started a program in biomedical engineering. So I wrote a proposal to NIH, and would you believe it, we had no labs, and just the 4 of us on the faculty, and we got it. And we had 8 years support for almost $800,000. So I supported 10 PhD students in biomedical engineering for 10 years. I was a PI. So it's amazing what kind of things you can do if you have enough gall sometimes. Okay, so I'm not going to worry about the other courses for the moment. All this happened later. The UFC activities in 1970. You may have read this in the book, but this was a year that Caprillion, who had been by then not only chairman of EE but dean of the School of Engineering, was appointed executive vice president of the university, and he decided he couldn't keep all 3 jobs. So he wanted to give up EE, and he called me to his office, and he said, he's going to split the E department into 2, because nobody other than himself could handle the whole thing. And so he asked me to be the first chair, and he said, well, it turns out he had asked Saul along the week before, and Saul turned him down. He said, we should ask me. So Bill Steyer was asked to be chair of electrophysics, and I accepted this job after complaining to Caprillion for half an hour. And I told him, look, I have a new NSF grant, I've got graduate students, I mean, I can't do a department chairman. And typical Caprillion, he said, George, you have no choice. That was the right Caprillion. And once he made up his mind, that was it. Okay, so anyhow, in 1984, Len Sutherland asked me to chair computer science because it had kind of a checkered history through this time. And so I helped get that department straightened out. Now they're a wonderful chairman, so I'm very happy about that. I also ran a center for manufacturing and automation. Actually, NSF gave me, over a period of 4 years, almost $4 million. And it was a center that included 4 universities. Cal State Long Beach, Los Angeles, UCLA, and USC. And I was a PI, so we had lots of money. I'm not sure we did anything terribly useful, but it was In 1983, I began the robotics program and created a lab. All of this is now current history. Silverman asked me to be associate dean for research for the last 3 years before I retired. I wanted to tell you about the Phony Pony because this was a robotics experiment and also a fun project. I don't know if any of you saw this before you retired, but anyway, this was a machine we built on the 2nd floor of Roland Hall. And it was designed to be a 4-legged walking machine. Actually, it was the first 4-legged walking machine in North America. So as I could tell by looking around everywhere. Anyhow, the story is here that, if I can see them, okay, so there are, you can see the legs, right? Where is the foot? Oh, here it is. Okay, so there are 4 legs, and you notice that each of the legs is kind of a horizontal foot. That was there so you wouldn't have to worry about lateral stability. See, that way it couldn't fall over sideways, only forward and backward. And there are 4 motors, one at each knee and one at each hip. And of course, like all labs, we never had any money. but I found an ad in the Sunday Los Angeles Times from Sears and Roebuck. They were selling quarter-inch electric motors for $25 a piece. So we bought 8 quarter-inch electric drills, threw away the drills, and put the motors in this machine. Sometimes, necessity is the mother of invention. I'm sure you've heard this story before. Anyhow, the other thing that's interesting here is, if you can see it, there's a curved cable going from this connection box at the back of the machine and down. So that was the cable that went from the floor, from the patio in front of the Lloyd Hall to the second floor of the computer. Because there were no microprocessors. This was in 1967. So the computer was the IBM 1620, a serial machine. It was on the second floor of the hall. And so that cable connected us to it, and it worked. It was amazing. It didn't walk very fast, obviously, but it did walk, and it had a variety of gaits. It could do the equivalent at slow speed of a pace and a walk and a trot. So, the guy who built it, actually, the guy was named, was a graduate student named Andy Frank. He had a master's in mechanical engineering, and then he got his PhD in lead from us. After he graduated, he went to UC Davis, where he gave up on walking machines and began to build electric automobiles. Wonderful guy. Okay, so that's that now. My research career. So I had support from all over the place. For one thing, I had a lot of courage, and I wrote proposals in areas I didn't understand very well. Frequently, they were funded. I recommend this to all of you. If you don't think you know enough, apply anyway. So, where did I get money? So I got money from NSF and so forth. Why United Cerebral Palsy? Well, I was consulting at Rancho Los Amigos Hospital at the time, and I knew the director of the kinesiology laboratory reasonably well, and I was on rounds with her, and we ran into this woman who was there with her son, who was severely involved cerebral palsy patient. And so he would look at her and say, oh, I'm listening to several people who say, oh, we try to talk. And she would say, you would like a glass of water. And I said, okay, now there must be intelligence in that garbled stuff that he was saying. So I realized that you couldn't just take those sounds and do linear processing, because it wouldn't change the relationships of the sounds. So it was totally heuristic. I invented a transformation that made it more intelligible, and got money from the United Cerebral Palsy, and we had a grant for a couple of years. It was very interesting work, and there was a scale of intelligibility from a university in Canada. Our original scale of understanding was 33%. And when we finished the transformation that I designed, we were up to 82%. So I thought it was dramatic, but the United Cerebral Palsy people didn't think so. They wanted 95%. So I had 2 years of support from everybody died. Over my 40 years, I had $17 million in research funding. There were a few years when I had actually 2 NSF grants. I had a lot of joint grants with various people, including Michael Arby and Bob McGee, Jerry Mandel, and toward the end with Maya and Ralph. So this was a very exciting period for me. I graduated 38 PhD students in the 40 years. Half of them were in academia and the other half in industry, and some have already retired. So when your students begin to retire, you must be getting older. We've had for 32 years a gathering of those students who were able to come in Los Angeles somewhere, and we've been doing that for 32 years. Okay, so my major areas of my thesis was in mathematical models of human operators. I also did some work in optimization by random search. That was a very interesting area. In biology and medicine, I was interested in breathing, and I think those pictures are not in here, but if I had time, I would tell you more about them. The story is that the cardiovascular system in the fetus develops on its own, but it can't oxygenate the blood through the lungs because the lungs will collapse in the fetus, right? Only when the baby is born do the lungs expand. Okay? So there has to be a way of allowing the blood circulation to reach its maximum level even though the lungs will collapse. So there's a bypass between the arterial and pulmonary circulation. There are actually two of them, but the major one is called the vena cava. And so what happens is that blood vessel shunts the blood that would normally go into the lungs back to the circulation. And so what happens is when the lungs inflate after birth, that reduces the downstream pressure dramatically, and so the blood can begin to flow through there, and that bypass vessel shrivels up and closes. If it doesn't close, you get a blue baby. So that happens. All right. I was very interested in system identification, along with Jerry Mendel and some other people. So the story here is the following. Cardiac output is the amount of blood injected by the heart per unit time. So it occurred to me that if I look at breathing rather than blood circulation, cardiac output is a parameter for the respiratory system because it shunts the blood into the lungs for oxygenation and returns it back. So the idea was if we could use parameter estimation to use respiratory data and indirectly estimate the cardiac output. Well, it almost worked. We got research money, but it didn't quite work out. Okay, I will tell you stuff about gait. We did a lot of interesting work on walking. The abnormal gait diagnosis was done as follows. I'm almost done with this. That we had a surgeon and a physical therapist in a conference room with blackboards all the way around, like this, and we had them list all the possible abnormal gait patterns that people are capable of when they're not well. Then we tried to go backwards from what was causing the abnormal gait. So it had been done forward, and we had to do backwards. Okay, anyway, we did all that stuff. A couple of things about unusual projects, and I'm almost done. So, the circulation story goes as follows. I was still a graduate student, and one of my professors called me into an office, and he said, Bekey, I've got a job for you. And I said, I'm writing my thesis. I can't do any other jobs for you. And he said, well, there's this guy at the medical school up in you should go see him. You're interested in weird stuff. Which is true. So I went to see him, and the story was the following. This guy at the medical school had called Professor Rogers, an engineer, and he said, I've got these lamps that I'm doing surgery on, and there's blood flowing against the pressure gradient. And I said, that's impossible. And that's what I told him. Well, he said, send me an engineer who can put this on the computer, they can figure it out. So that's what I did. I went to see him. It turns out the blood was not flowing against the pressure gradient. It was flowing with it, but slowing down. And the pressures changed. So the guy didn't understand this, but anyway, we got some funding. We did the work at UCLA. Originally, when I was a student, came to USC, and I right away got a grant from NIH to continue this work. So, it's a very interesting area. Anybody who's trying to tell you more about this later. And it's published, including in the American Journal of Physiology, which is the great journal of physiology. Okay, so the third idea down there, oh yeah, the CP speech. Well, I think I already mentioned it, yeah, we skip that. So So the sensory feedback for improved standing stability. This was one of my good ideas that didn't work. So the story here was the following. I thought, see, the problem with many paraplegic patients who are paralyzed from the waist down is that they have no feedback. So they don't know whether they're starting to fall. So I thought, let's do the following. Why don't we start out with accelerometers on the legs and see if we can get some kind of feedback on what's happening to the body, and then use it to tickle around the waist on the right or on the left. And if it's tickling on the right, that means if you're falling that way, then it's turned out this way. The patients had no feedback at all. So this was a way of giving them artificial feedback. There was another one of my good ideas that didn't work. Why didn't it work? Well, because after a relatively short time, they quit feeling it. So we had to turn up the gain on the amplifiers that providing the signals until eventually it hurt. And that has to do with habituation. See, I mean, the human body is very adaptable. And you keep stimulating it, and it gets used to it. And you need a stronger stimulus to get it working. That was a good idea, but it didn't work. I strongly believe that we should experiment with our good ideas, whether they work out initially or not. That's how exciting things happen. Okay, let me skip the muscles about walking. Tell you about the horse. Well, this story here was a young woman named Patty who came to see me one day and said, Dr. Bekey, I'd like to do my PhD with you. I said, that's great. What do you have in mind? I said, well, I have one condition. It has to be about horses, because I'm a horse nut. Well, she was indeed a horse rider and owned a horse. So she wanted to do something involving horses. And it took us a long time to find something we could do. But you know, since I've been known to be weird, so here's what I did. I went out and bought a horse, a plastic horse. And then I had okay. So I'm going to speed this up. It's almost 10 minutes to 3. So and then because I was consulting at Rancho Dominguez Hospital, in the lab where I was, there was a wonderful technician who could do anything. So I said, I have this plastic horse, and I'd like to be able to control it. Can you make me a set of reins for the horse with sensors in the end, so that if you pull on the reins, you can get electrical signal. And then can you build me some pressure sensors that we can put under the knees of the rider on the plastic horse, so that we can get that signal into the horse. So that's what we did. And so a person was able to sit on the plastic horse and get control signals from the reins and from their knees. And they went into a simulation of the horse on a computer. And so whatever control signals the rider imparted to the horse, we could see it on the screen. It was actually sufficiently good so that we had experienced riders sitting in the plastic horse watching the simulation on the screen, and they said it's just what it would have been if it was a real horse. Anyway, I'm not going to bore you with all this, but it was a very interesting project, as you can imagine. Since I'm already known as being weird, bringing a full-size plastic horse into the lab, and in the lab next door, everybody thought it was kind of strange. Right? Anyway, that's what it was. So that's the horse. I'm not going to talk about this right now. There are other people in the room who know more about this. Okay, this was the first USC robot. This was a genuine Puma programmed in the universal manipulator. I bought this in 86 or something. I've forgotten, somewhere around there. I got $87,000 from NSF to buy the robot. This was a group with some of my students. You may recognize one or two on there. The assorted robots that the students built in the lab during that period. Some wheeled, some legged. Let's see, what else can I tell you? There's a guy here on the right, the second from the right, you probably recognize. This one here is now a professor at the University of Oklahoma. This guy on the left is a Google. Interesting group of people. Okay, so the last research project, when I retired from here in 2002, we moved to San Luis Obispo, and there's a university there, one of the California State Universities. And I found in a story in the local newspaper that there was a guy in the philosophy department who was interested in robots. So I went to look him up. So his name was Chris Clark. No, sorry. Not Chris Clark. Chris Clark was a engineering professor. But anyway, I went to, there are two stories here which I'm mixing up. Chris Clark was in computer science at Cal Poly, and I suggested that we consider the idea of designing a system with altruistic robots. That is, robots which, when they saw another robot in the group not doing well, they could go help. I mean, really altruistic. And it sort of worked, but NSF didn't like it. Robot ethics had to do with a guy in the philosophy department who was interested in this field. I met him. We first got some money from ONR and then from NSF, and so since ethics had always been of interest to me as well, we worked on first with the philosophy department and engineering, and then we published this book, Robot Ethics, as some of you see. So I think that's just about all I have to say. Published a bunch of stuff, a lot of papers, several books, and Robot Ethics was the last, published in 2012, actually, by MIT Press. So that's just about it. This book, which many of you know, was supported by Dean Yorsos, and my daughter Michelle, who is here in the audience, was an enormous assistance in getting this book together. And that's about it. I was very lucky. I won a number of honors and awards. I was named a university professor in 1999. That was a very important appointment for me. The university professors are truly remarkable people because you're named to that because you're interdisciplinary by nature. So, of course, Saldo was a major element of that. Now I'm at Cal Poly part-time. I have an adjunct appointment in engineering, and I'm part of a group called Technology Ethics. So we're really interested in it. And I'm on the advisory board for both the EE and the Environmental Engineering Department. I also, for several years, directed and I wrote a proposal and got an REU grant. I think Gaurav had an REU grant here also. These are research experiences for undergraduates. And so, now the latest thing is there's an enormous interest in automatic strawberry picking. San Luis Obispo is surrounded by strawberry fields. We're sort of one of the centers of the strawberry industry. And the problem is, you can never find people to pick strawberries. Every field you go onto has huge signs in Spanish advertising for strawberry pickers. And people don't want to do that anymore. And so, developing machines that can do this automatically is one of the current areas of interest in agriculture. And there is a machine, it's called an agrobot, made in Spain, which has 12 arms. And 12 arms go out, each picks up one strawberry at a time. So I think agricultural robotics, if any of you are interested in an area with an enormous future, this is it. Because human picking in the fields is disappearing, and very quickly. 20 years ago or so, when we developed a robot hand here at USC, I took it to Davis and said, I think this would be a great machine for picking oranges and other fruits like this. And they told me, well, that's not a good idea, but we have a lot better way of doing it. It's called Mexican labor. Well, that's not true anymore. You can't get people to do this kind of thinking. And so, anyway, there's a huge field for robotics, and they're developing almost every day, every week you read something new. There's one in Salinas, which is called the lettuce bot, machine for thinning lettuce planting fields. So I keep reading of new ones and stuff. Anyway, I'm an advisory group. So that's it. I'm writing my autobiography. I enjoy the Central Coast. I spend more time with my wife, to whom I've been married for 65 years. And I plan in this lifetime to clean up the garage. Now, not everybody can say that, but I'd like to try to do that. And find as much meaning and satisfaction in life as possible. So thank you for inviting me.
Jeff?
Yeah, George, do you want to say anything about how much of an influence the recent work on motor prostheses has influenced the understanding of, for robotics? Has that, brought to the robotics field more that they, a better understanding so that robotics can move faster and further? Or are those two fields separated?
Well, I think they're still two separate from my point of view. And my feeling is that the people I know who work on prosthetics, that kind of, are all interested in robots, but they don't have the engineering background to work on them. So, and many of the people in engineering in robotics don't have any background in biology, and they don't know quite how to interface with it. But I think there's a huge future. It's just enormous. So I'm glad you brought that up. I hope somebody in the room picks it up and gets an NSF grant that does something. I had, in my 40 years at USC, I think I had 38 years of NSF funding. So I know it can be done.
George, I have a question about our future assistant professors. And looking at your trajectory and how you did what you were interested in, and you did what was novel, and you did what was weird, and thinking about our future assistant professors and how they're on a track to figure out how am I going to make it in this competitive environment? How am I going to get tenure? How am I going to do the things that I have to do to keep doing them? And all of that is in opposition to being creative and being bold. And so what can we say to them so that we get something that isn't just, okay, this is really good, this gets you tenure, okay, this is great, but something that's going to change the world. How do we get brilliance out of it?
Now this is a very, very good question. I mean, I personally think we can do both. That is, you can pursue your own interests, however weird and peculiar they are, because it's amazing what the government will fund. You can really find unusual things. And as I said, here I am an engineer, and I got stuff funded on the speech of cerebral palsy patients. So there's a lot of stuff that can be funded, and the number of opportunities for collaborative work is just enormous. I think now Yanis has been terrific at giving us close collaboration with the medical school and so on. So I think we're in a very good place where you could write joint proposals with people in medicine and biology and physiology and so on, and get funding for fascinating projects. So I think the answer is you can do both.
So I think perhaps that's a great segue for us to let George sit and to continue the next phase as a conversation. We'll leave time for questions again from the floor. I think one of the occupational hazards of being somewhat older than the others in the room is that you get asked for advice.
That's true.
And so I'll begin there. If you had advice to give to a new assistant professor or a grad student about taste in research and how to pick problems, what would you say to them?
Well, the first thing I would tell them, they should read the blurb I wrote called Assistant Professor's Guide to the Galaxy. If all assistant professors in the room haven't seen it, you should. I'm sure Gaurav has a copy.
I do have a copy.
And you can make copies of it if necessary.
Absolutely.
Yeah, okay, so that's the first thing. Now, the, the second thing is that I think it's important to follow your own muse. I mean, you really have to look at things that you're interested in. And if you have the kind of a mind that most of us do, you not only read about something going on, but you say, "Now, but how did it get to here? And how can I make it better?" Right? I mean, these are things that all engineers ask. And so I think what you need to do is to explore those possibilities, and then, if necessary, find collaborators. You know, I mean, we're now at a time when our dean is very much pushing collaboration. We have a joint program with the medical school, right, which is going very well. So I think we're in a wonderful. You guys are in a wonderful time to begin to explore new opportunities. And just because you have an idea and you don't know how to move forward with it, don't give it up. I mean, it's the ideas that are the groundwork of new inventions and new theories and new possibilities. So the thing to do is to find collaborators. That way you can take advantage of the fact that your own ignorance can bring somebody else in and do it right.
That's an interesting insight. Maybe that's one place to explore. I want to take you back to the beginning.
Okay.
When you first came to USC,
Right.
What was it like? What was it like to be an assistant professor? You said you shared an office, and
Right.
I hope all the assistant professors are listening loudly. You shared an office with 2 other assistant professors.
That's right.
So that was one way in which it was different.
But we had a window.
You had a window. There we go. So what else was different?
Well, one thing that was different is that the department had no money. And I really mean no money. I shouldn't say this in public like this, but our chair at the time said to us, some of you guys, when we met in department meeting, said, some of you guys work at Hughes and at TRW, and I believe that they have supply cabinets at the end of the hallways, and we desperately need pencils and pads of paper. He didn't say any more than that. That's where he stopped. But so the point is, things were really different. There really was no money.
And how would you sort of characterize, how was it in terms of the teaching environment? What was the expectation when you came to campus first?
Well, Caprillion gave me the first semester that I arrived, I had 3 courses. But
In the first semester?
First semester, right, without having a chance to settle down. But fortunately, 2 of them were 2 sections of the same class. So that was an enormous break for me. So, and then he said, be sure to write a proposal or 2 because you need money. And I don't have any. I mean, that was, that's always Caprillion's reply to everything. So, so that's what we did. And, and I came with having had the experience of, so there were basically 3 projects. One was this walking business and so on. And in all 3 areas, I wrote proposals, and within a year, I had 3 grants. So I think part of it requires courage. Go ahead and do it, and get advice from other people. But I think proposal writing is a very creative activity. Many people don't think so. But I think when you write a proposal, which means that you now try to formulate not only the questions, but the possible approaches to those questions, I think that's how your own mind grows, and you develop it this way. So I really think that writing proposals and therefore being able to succeed in bringing support for yourself and your students is the way it works. Does that help?
That's very interesting.
Yeah.
How would you characterize sort of the nature of the research environment? Were people collaborative? Was there a culture of collaboration? Was it being built as you went? How did it function?
Well, there were both kinds. I mean, they both happened. In computer science, when Per Brink-Hansen was brought in by Caprillion to be chair of computer science, he met with the junior faculty and said, I don't want joint papers.
Ouch.
Each of you guys should sit in your own office and write papers.
All right.
Well, so that was different. Okay? In electrical engineering, Caprellian encouraged collaboration. But on the other hand, there were so few of us, and we worked in so many different areas, that it was very hard to get the collaboration. You know? So many of us worked with our students. We had to do what we had to do. For example, with Phony Pony, with the horse that we built, it was Bob McGee and I had met this graduate student. His name was Andy Frank, who was a mechanical engineer. And so we were chatting about this one day, and he said, I think I can build one. So, we encouraged him. And there were certainly places where there was no money. And as I say, I bought those motors for the joints out of my own money. And I didn't have much, I'll tell you. But there are times when you have to do things like that, I think, to get things moving. Later on, when Caprellian began to have a little money, I learned how to work with it. I would go to him and say, I have a new project and I need 6 desktop computers, and I have money for 1. Can you find me money for 5 more? And he said, well, I'll find you 4. I mean, that was the kind of negotiation that we had to do with Caprellian. He would give you nothing if you didn't start out with something. I said, well, I had money for 1. And I asked him for 5, but it was typical Caprellian. He said, I'll give you 4. So yeah.
So I guess is it fair to characterize that when you came to USC in the 60s,
Yes.
That there was a spirit of entrepreneurship about how faculty approached their role?
Very much
And
so.
they essentially created their own roles to the extent possible. They went out and did things.
That's right. That's right.
Is that-
I agree
is
with
that
that.
a fair characterization?
Yeah, it's a fair characterization. And as you know, because you were involved in some of this, in the early days, we had to do a lot of things ourselves because even though when you were a student, things were better than when I first came, but even so, when we built the robotics lab, there was no money to get electricity to all the workstations that were there. So, for those of you who don't know the story, we had the lab in, and it had, so this was in, which building was it in?
So it was in Salvatore.
Oh, Salvatore, that's right, Salvatore. Yeah, and so anyhow, we got a room with a false floor, which wasn't being used. And so we came in on a weekend. I was a reasonably good electrical contractor, so I brought in with huge amounts of conduit and wire, connectors and things like this. And so Gaurav and other students came in with me. We picked up a false floor, laid out the electrical conduit with risers going up right next to each computer, and over a weekend we got it done.
And I think the picture you showed was taken just a few months after that was done.
think
I
that's
remember
right.
that.
Yeah.
Yeah, that's very good.
So but I really think there are other ways of being an entrepreneurial without having to do it. Now you couldn't get away with that sort of thing. I mean, the university wouldn't let you. Or like the time when we had no air conditioning, but the room next door had a computer with air conditioning, and I came in on a Saturday and drilled a hole in the wall. Well, we got air conditioning.
But you violate the code by not getting electrical permit, stuff like that.
That's true. That's true.
So George, if you would, maybe we can go even a little further back.
Okay.
Tell us a little bit about your parents. You alluded to your father being an electrical engineer.
Yes.
But I believe your mother was a trained chemist, if I'm not mistaken, or
No,
attended
she
school
she actually got a degree in chemical engineering.
in chemical engineering.
And that's kind of a strange story about this because that's not what she wanted to do. She wanted to be an architect. And her family said architecture is not the appropriate field for girls. So she began to look around for something else, and she picked up chemical engineering because her family didn't know what it was. So they didn't object.
I note that our dean, who's a chemical engineer, is just left. Otherwise, I should have asked this before he left.
That's right, you should have, yeah. So
Excellent.
anyway, she worked in a soap factory when I was born.
Yeah.
And So, but you know, this was a very early chemical engineering. So by the time I got to chemistry at UCLA, she didn't understand what I was doing at all. So she couldn't help. But yeah, so, but she had an analytical mind, you know, so she was a remarkable woman. Also very attractive at her youth. And you can see her pictures, I can show you. She was a lovely woman.
And if I remember correctly, your brother worked for NASA for many years.
Yes, my brother Ivan also went to UCLA, also got a degree in electrical engineering, and then he worked for McDonnell Douglas for a number of years, and then Aerospace Corporation, at Aerospace he met guy who then became the head of JPL. I'm sure some of you know his name, but anyway, I'll think of it later. Anyway, he went to Aerospace, and then when this guy went to NASA headquarters, Ivan followed him. And he was at NASA for maybe 25 years or longer. And he had the best title of anybody I ever knew. When I went to see him at NASA headquarters, the title on his door said, Director of Advanced Programs. Isn't that a wonderful title? I mean, I'd love to have a title like that. So he was there. Eventually had a disagreement with he was like number 3 in command of NASA headquarters. And then he left. There was a big political battle, as there often are. And for the last 15 or 20 years, he still consults, and NASA is one of his customers.
Oh, interesting.
Yeah, he also consults for Paramount Pictures. Whenever they have a space movie and they want to know, you know, whether we can build a spaceship and get to Mercury, well, they call him.
Very interesting.
Yeah.
Very interesting. So you sort of engineering and science in some ways was in the family.
Very much so.
Very much so.
Very much so.
So if you had to, you showed us a picture of going off to school when you began first grade. If you had to reach back, when do you think you sort of detected what's your earliest memory of being interested in science or engineering, or some intersection of the two?
So that's a really good question, Gaurav, because I've thought about that, and I don't know. I do remember that during the summers, but this happened more in early, like junior high and times like this. I worked for my dad during the summers. And so my dad was an electrical engineer, and his specialty was electric motors. And he had 6 or 8 patents. I can't remember how many. He designed some unusual motors. And he had this little tiny place on Main Street in Los Angeles with 2 guys working for him. And he would design and order the laminations that are bolted together to create the armature of an electric motor. And then he would wind them himself, or have one of his guys do the winding. So, but he was very creative. In many cases, he ran these motors at flux densities 5-10 times higher than what was normally done. And so I remember he once showed me a 100 horsepower motor that he built for General Electric. I mean, here was this little guy in LA with 2 guys working for him, and both Westinghouse and GE ordered motors from him. Motor was about this long and maybe this big around, 100 horsepower. It was water cooled. But that's the sort of thing he did, you know. And it was very. I tried in his last 5-8 years of his life to encourage him, and I said I would help him. You should write a motor design handbook because you've got techniques nobody else has. He didn't want to do it, so he died with him. Very interesting.
And when do you think it became clear to you that being an academic was something you wanted to do?
Well, okay. Excuse me, that's an interesting question, because I worked for my dad during the summers and sometimes on weekends. I was doing 2 things. One is winding motors, so I got pretty good at that. And then I was also an errand boy for him. You know, I'd go to some shop and pick up laminations and a wire and so on. So that's what I did. But what I wanted to do myself was really not clear until I went to college. I went to UCLA, And I had this thing from my dad that maybe I really was interested in motors. And so during my year at Berkeley, my major professor, whose name was Saunders, was a power person. And he and I got along very well. You know, we had lots of long chats and things like this. And he encouraged me to explore other things. So I came back to UCLA, and I really never did very much with motors after that. In my first course at USC that I taught here, I did do lectures, and I wrote some notes. I still have some handout notes on synchronous motors and things like that. In fact, I looked at one of those not too long ago, and I don't understand what it says, but I know I wrote it.
So it's fair to say that maybe by senior year you knew that you were probably not going to follow your father, and probably not.
Yeah, well, actually, it was in my junior or senior year when my dad said, "I want to retire. Why don't you take over my business?" And he had amazing customers, Bendix and GE and companies like that. So I thought about it, but then I said, "Gee, if I go to work for him and take over the company, I'll never go to graduate school." And I really had a desire to teach and go to graduate school. So I turned it down, and he was heartbroken. I mean, he really thought that I could take over Bekey Electric Company, which is what it was called. So it never happened.
Very interesting.
Yeah.
So one thing I wanted to touch upon, you alluded to it in your talk, and it's something that I think has been an abiding interest for you. It's that in spite of being a engineer's engineer, you've always been interested in broader issues concerning humanity, spiritual issues, sort of issues of how to lead a good life, things like that.
Right.
And you alluded to the fact that you even attended, a theological school for a while.
Yes, that's right.
I think I've seen your transcript from those days. You showed it to me once. For the record, he got straight A's, and so he was all set. But then you decided not to continue. How do you think that's influenced the way you've done research? What has been the interplay between thinking on the one hand about religion and philosophy and about how you do research?
You know, I thought about that myself, and the answer is that I don't think I know. I don't think the two have mixed as well as you might think they would. See, certainly I've been interested in some things like ethical issues for a long time. I mean, I remember writing an article for the California Engineer, which was a student engineering magazine for the campus of the University of California, in which I was concerned about people cheating on their designs and things like that. So that was a concern for a long time. But other than that, I really can't tell you very much. I mean, I've always been interested in some sense in doing the things that were right, but I really couldn't tell you what I meant by that.
That's interesting.
Yeah.
One of the stories I was hoping you would talk about. Some people in the audience may have heard the story, but you were intimately connected with the creation of ISI in an unusual way. You were at the center of events when some very interesting things happened when ISI came into being.
That's true.
So I wonder if you tell the story. Take us back to the early 70s.
Sure. So this was, well, the year is somewhere in the book. You're going to have to look at the book. I can't remember.
74 maybe.
74?
I'm guessing.
Somewhere
Somewhere in
around
the
there.
70s.
72.
72.
72. Yeah, so what happened here was that I was chairman of EE Systems, or EE before it was Systems, I can't remember. And just at that time, the computer group at RAND Corporation had decided to leave from RAND. And there were two issues. One of them was that because whatever his name was, the guy who published the Pentagon Papers,
Daniel
Ellsberg had published the Pentagon Papers, and he was at RAND. So the Pentagon Papers didn't sit well with the Defense Department, as I'm sure you know. And so they influenced the president to cut the funding for RAND. So, and particularly, they wanted to cut the funding for for computers. Okay, so that was one of the things that happened, and so the guys at RAND began to look for another home, because they knew they had to leave. Well, at that time, I was consulting at RAND. They were experimenting with a computer called the Johnny-Ack. This is the Western version of the John von Neumann computer that had built at Princeton. So, and I didn't know anything about the computer, but I had a rough idea what the programming techniques were. And the guy who brought me in was a mathematician named Ed DeLand, a wonderful guy. Unfortunately, he died about no more than a year ago. He was at UCLA. Anyway, so what happened was that he had developed a set of equations for a biological system of all things, and he asked me to see if I could program them to run on the Johnny-Ack. So for a day a week for maybe 6 months, I drove to RAND, sat in front of this keyboard. I didn't know what was on the other side of the wall, but all I had was a keyboard and a screen. And I tried to program that thing, and almost every time when I did it, I crashed the computer. So they were saying that the reason DeLand brought me there was to figure out how to crash the Johnny-Ack. So anyway, that was interesting in and of itself. But we got acquainted, through that time, and that's how I met the guy who was the director of the computer group at RAND. His name was Keith Ankerfer. So then, after Daniel Ellsberg published the Pentagon Papers, and the whole computer group decided they'd better get out of there because their funding was being cut, started looking around. Well, so Keith Ankerfer, who was the director of the group, went to UCLA first. And he met the dean, nice guy, I remember the dean quite well at UCLA. And he said, well, we'd like to have you, but the University of California is a complex organization, and if we get you approved through the provost's office here, we'll have to go to Sacramento. This is not an institute we can start without approval from headquarters. So Keith said, well, that won't work, and he tried the University of California at Irvine, he got the same response, he couldn't do anything there. So then, people said, well, there's only one other place for you to try, and that's USC. Do you know anybody at USC? Well, I had done consulting at RAND, so I knew him, you see. So he called the only guy at USC that he knew, and that was me. So Keith came to see me in Olin Hall, and we chatted for a while, and he explained what he had to do, and I said, Keith, this is too important a decision for me to make by myself. Can you come back tomorrow or the next day? So we arranged for the next day, and I had Jack Mnuchin, who was sort of the right hand of Caprillion, join us, as well as somebody, I've forgotten his name, who was the director of grants and contracts at the university. And so we had this long meeting, and they explained that they had to leave from RAND, and where could they go? And I said, well, we would love to have you, but this is a decision that I can't make. And so we have to get Dean Caprillion involved in this. Well, Caprillion was doing 17 other things besides being Dean of Engineering, but fortunately, Mnuchin, who had been a friend of Caprillion for 20 years, from the time they were roommates at Berkeley, was now sharing a house with Caprillion. So I told Jack, listen, you can't let this go. You gotta go talk to Zorab and do it tonight, and let's schedule another meeting. So a day later, or 2 days later, Keith Ankerfer got a phone call from Contracts and Grants at USC, arranging a meeting for lunch with Caprillion. And his first question was, who's Caprillion? Right? I mean, that was the logical question. So anyway, they met, and then this is kind of history, but anyway, Caprillion said, I can't just bring an institute like you into the university. I have to get permission to do this. So, give me a couple of days to think about it. So then, it turns out this was like on a Tuesday, and on Saturday that week, there was gonna be a Board of Trustees meeting of USC. And Caprillion said, well, I'll go to the Board of Trustees and present them with this idea. Well, on Thursday, he had lunch with Keith Ankerfer, and they talked some more about what could be done by bringing that institute to USC. On Saturday, Caprillion went to the Board of Trustees meeting and said, I'd like to tell you about a new institute that is joining the university. Well, I mean, you know, that was Caprillion. He took the bull by the horns and didn't hesitate. So that's what happened, and he didn't ask for permission to do it. He just, this is the new institute that we're having. And then he went to the Board of Trustees meeting on Saturday, said, I've come to tell you about our new institute. So that's how it happened. It took like 6 days. Caprillion was an unusual guy. I cannot tell you.
That's a great story.
Yeah,
It's
I
a
think
great
it's a
story
wonderful story.
in sort of creating something and sort of maybe
Right,
captures the
right.
spirit.
And I was very pleased that I was kind of at the beginning of this thing, because I was the only USC person he knew, so that's how we arranged it. And then I knew when to step out. And it worked well, so.
That's wonderful.
Yeah, I think it's great, and now, so ISI is a very proud part of USC.
Absolutely.
And our president keeps saying it's the crown jewel.
Absolutely. Wonderful point.
Right.
So perhaps we have a little bit of time to open it up if there are some more questions from the floor. I see Ted's hand is up.
I have two questions. One is to follow on the story you just told. At some point, somebody must have been hit with the budget, you know. I mean, to tell the Board of Trustees that now we have this new institute joining, sort of
Yeah.
begs the question of who's gonna pay for it all. But
Okay,
the,
so,
okay, go ahead.
there's another part of the story that makes that possible. So what happened was, while Ankerfer and Bob Balzer, who were the two leading guys of a group of about 6 that were looking around, eventually they all left, but Balzer, Ankerfer, and one other person whose name I can't remember. Ankerfer by then had a number of contacts at DARPA. And so he called somebody at DARPA who he knew. And the first 3 days after they left from RAND, the 3 of them sat on the floor of a rented office, so I'm told. I mean, other people have told me, no, that's not true. They had chairs they borrowed from somebody. But anyway, they were on chairs on the floor, and they wrote a proposal. And in those days, DARPA gave some grants which were open-ended. If they trusted an organization and its leader, they would give them open-ended grants with no specific goal.
oh my God.
So it didn't last for many years, but it did last long enough for
Right.
Ankerfer to get, I think, $3 million from
6.
DARPA. And
Six.
with a crew of 3 people. And you know, a few days later, the empty office where they sat on the floor had furniture, and they moved forward. Ankerfer was another guy in a sense like Caprillion, you know, the courage of his convictions and willingness to try something that was difficult or impossible.
My second question has to do with your role, your founding role with biomedical engineering. You really had everything to do with starting biomedical engineering here.
Yeah,
I
well, look,
wonder
so-
if you could talk about it.
Electrical engineering existed when I came. We had a chair of electrical engineering. It was an acting chair at the time. His name was Homer Grant. He was acting electrical engineering chair and really chair of industrial engineering. But he signed my offer letter. So Caprillion was, of course, the head of electrical engineering. So, and at that time, there were maybe 5 or 6 of us, I can't remember, maybe 6. And almost every afternoon, around 2:30 or 3, Caprillion would come into the 2 offices where the rest of us had our desks and say, let's go for coffee. we'd all go out for coffee and talk about things that, you know, we wanted to do and things that needed to be done. And there was a kind of a camaraderie at the beginning where we all felt we were part of a team. And so that's how it came together. By then, Golam had accepted. And then within 6 months after that, Brilliant came running into the office with his hands way up in the air and says, Irving Reed is accepted. So once we had Reed and Golam, then Caprillion set about creating the Magnificent Seven or whatever that, you know, the group of communications people was. So you know, he was an amazing guy because he had this vision and no resources to carry it out with. But it worked, and the strength of his convictions and his there's a certain magnetism to him. You know, I mean, he was this ugly, short guy, but he convinced people. You know? I was one time in his office. I was walking by, and he said, "Come on in, George." And there was a man talking to him, and he said, "You know, please agree with me, with this man, that we desperately need money to really build electrical engineering." And so I said, "Well, whatever Dr. Caprillion says is right." So, and Caprillion said, and I remember these words extremely well, Mr. whatever his name was, "You have to help us." I mean, he was so blunt about these kinds of things. Well, so the guy donated money.
And when did you, when did the first sort of conversations about creating a biomedical engineering department?
Biomedical engineering came significantly later.
Right.
Yeah, probably at least 2 years. And so Caprillion had never heard of biomedical engineering until I came, and I had published a paper or two. So then he got intrigued when he realized that there was money there. And so, well, I mean, that's the way he worked. So I wrote a proposal, and I got some grant money. And so then he really began to look up. So, well, maybe there really is such a thing. And so we first hired 2 assistant professors, a fellow named George Moore, who was a neurophysiologist from UCLA, and then a fellow named Matt Wolf, who was an endocrinologist. So, so those were there, and then a curious thing happened. A brilliant respiratory physiologist from Northwestern University had spent the summer at RAND working with Richard Bellman. You all know about Bellman and dynamic programming and related things, okay? So Bellman at that time had an interest also became interested in biology. Except that being Bellman, he didn't want to call it biomedical engineering, he called it biomathematics. That was, you know, put a bio in front of it and it became useful. So, so Fred Grodens, the respiratory physiologist, spent the summer at RAND working with Dick Bellman. And so then, and I've forgotten the details of this, whether Caprillion first brought in Bellman or he first brought in Grodens, I don't remember. I think it was maybe even Bellman. So Bellman came to USC, and Grodens, who was spending the summer at RAND, said, I came to work with Bellman. If Bellman is at USC, I'll go also. So that's how biomedical engineering got started. And the first 4 people were Fred Grodens, Matt Wolf, the endocrinologist, George Moore, who was the neurophysiologist, and myself. And I don't know what I was. I mean, I was an engineer. The others were more biology and physiology than I was. So those were the 4. And then something I intended to mention as part of my talk, but I forgot. So there were the 4 of us. And after a year, we realized we really couldn't do anything. We had no resources. You know, we didn't have a department. We didn't have any budget. We couldn't do anything. So by then, I had met a bunch of people in biochemistry and biophysics and at the medical school and so on. So I called a meeting, and about 20 people came. Would you believe this? 2/3 from the medical school and 1/3 from on campus, because biochemistry had a department on this campus as well. And I said, you know, if we all work together, maybe we can get the money to create a department of biomedical engineering. And so, and I talked about my vision about what to do, and I said, each of them, I'd like to come and see you in the next week or two. If you could write a paragraph for me about what you could contribute to such a thing, I'll try to assemble the whole thing into a proposal, which I did. And the proposal was absolutely incoherent. And so, we had these paragraphs from 20 different people, and they didn't fit together. Okay? And we had nothing. I mean, there was no department by that name, and we had no budget. But anyhow, unknown to me, but as a fortuitous circumstance, NIH had just announced a training program in biomedical engineering. For the first time, they had training programs in other fields, but so when I submitted this proposal, it came in just exactly at the right time. And so here I had applied for this. We had no faculty. You see, these people were all from other places, and we had no labs. I mean, zero. We had absolutely nothing. So anyhow, I wrote this proposal, and it was funded, and we got $100,000 a year for 8 years, as I remember. And so, sometimes it takes gold to get moving in academia. I've taken a number of risks over the years, and generally they paid off. Not always, but generally. I encourage all of you, if you have a vision of something, try to go after it. The field, engineering faculties, engineering schools, are full of people who don't have a very strong spine, if you'll forgive me for saying so. And I mean, some of them are, of course, but in general, they don't want to stick their neck out very far. I suspect all of you have noticed it to some extent in some areas. But anyway, so if you have courage, it's amazing how much you can accomplish. So, anyway, we got a grant, and I was the director, and so I had enough money to support 10 PhD students for 10 years. That's what got biomedical imaging started, you see.
That's a wonderful story. And so maybe we'll take one student question, and then I'm getting a signal from the side that we should segue to the next part of the program. Professor Bekey is going to be around. There's going to be a reception. You can all stay, pepper him with questions.
Good.
So let's take one more question from the floor, perhaps.
Hi, Professor Bekey. I'm Eric. I'm an undergrad. I'm just wondering, like yourself, I have a lot of diverse interests. I'm an electrical engineering student, but I was...
Would you mind speaking up a little bit?
Yeah, sorry.
I don't hear as well.
Yeah, I'm an electrical engineering student, and I have a lot of diverse interests as well, and I really like to hear the story that you did a lot of different fields. You got involved in a lot of different fields, but in terms of time management, and everyone only has a certain bandwidth, how do you kind of balance learning something yourself rather than bringing someone in as more of a consulting role, and how does that tie into the overall growth of your career?
So how do you manage your time? So you
How do I manage my time?
Given you have diverse interests and you have
Yes.
a certain amount of bandwidth,
Yes.
how do you decide when to learn something on your own, when to collaborate, bring someone in?
I understand. Okay, so I have two answers to that. One is that for essentially my entire 40 years on the faculty, I always took work home in the evening. I know faculty members who don't do that, and they don't work on weekends, but I always have, and you have too, I'm sure. So I think university faculties are such that if you don't put in extra time beyond what's expected from you, you'll accomplish nothing. So, and I guess I knew that or expected that, but I always carried work home, and so what I did is I stayed up, had dinner with the family, played with the kids, put the kids to bed, and then I went back to my desk. So, and I did that for many years. So I think that's one of the things I do. To answer your question, a lot of it was extra time on my part. The other thing I did with PhD students, there just was never enough time on campus. I had courses to teach, committees, innumerable committees, all these things to do. So any number of PhD students came to my house on weekends and we worked on their thesis. Did you, Marty? I don't remember.
Yes,
Yeah,
Dr. Bekey.
that's right. So
This is in
that's
the-
one of the things I think. If you accept the fact that their academic appointment is gonna take a lot more than 40 hours a week. I mean, that's the first thing you have to accept. And I figure I work 60 hours a week anyway through all this period. But there are also satisfactions that a lot of people don't have. So that worked very well. And I had wonderful relationship with students. You know, I graduated 38 PhD students in my 40 years on the faculty. And for the last 30 or 32 years, we have an annual gathering. And 15 or 20 students come every summer. I mean, it's amazing. I think Monty organized the first one. And so, but it's a wonderful group. You know, there's a level of camaraderie that we have, which we forged in the early days. I think it's a wonderful thing. So I don't know if that answers your question, but one of the answers to your question is extra time. You know, you just have to accept the fact that there are football games you can't go to. And the second thing is that you really have to manage your time and work on priorities pretty carefully. So my wife never liked it when I brought home a briefcase in the evenings. And I didn't do it 100% of the time, only 95% of the time.
That's wonderful. So perhaps in the interest of moving on to the next phase, George, thank you so much.
You're welcome.
This is a wonderful conversation. I wish we could talk some more. Let's talk one-on-one.
Good.
And I invite all of you to stay for the reception.
Terrific.
Thank you very much. So if people have gathered around, we'll get out of the way. Maybe strike a pose for the camera.
You know, I brought Jerry Mendel to UFC.
There we go.
If you could do it on there, just.
You want me to pull this man?
Pose first.
Just like that?
Yeah, go for it.
Count to 3.
Okay, 1, 2, 3.
There we go.
Yeah. It looks so formal.
I know, it's so formal.
Thank you.
Wonderful. Thank you so much, George.
Here's one of my distinguished PhD students. And another one. And another one. Why don't we get the PhD students over here?
Yes.
Somebody else take it. Hey, Gaurav, you belong here. This is the former students gathering. Good. Gaurav, why don't you go on the other side? Overextended on this side. Oh, that's good. That's very good. Yeah.
I'm Dr. Bekey's student 46 years ago.